The world's most valuable resource is no longer oil, but data. The quote from The Economist in 2017 holds true even more so today. Data in the 21st century is like oil in the 18th century. As we've seen in our previous videos, Internet of Things is one of the pillars of the fourth industrial revolution. With the increase in adoption of different technologies such as machine learning, augmented reality, cyber-physical systems and Internet of Things, the world of digital transformation is about to take another leap in the next few years. According to the famous futurist Ray Kurzweil, we are living in one of the most exhilarating times in human history. The evidence of dramatic change is all around us, and it's happening at exponential speed. Humans are linear by nature. We tend to link events up logically in a linear flow through space and time, so it is difficult and against our intuition for our minds to comprehend the technological changes that are happening now. So here's another way to think about it. Take 30 steps linearly and you get to 30. 1, 2, 3, 4. Step 30, you're at 30. With exponential growth, it's 1, 2, 4, 8. Step 30, you're at a billion. So taking 30 linear steps is not going to get you very far, but taking 30 exponential steps will be the equivalent of traveling around the world 26 times. The fundamental measures of information technology follow a surprisingly predictable and exponential trajectories based on the Moore's law. In 1965, engineer Gordon Moore predicted that the number of transistors on a chip would double every 2 years. More than half a century later, this trend continues despite predictions that it cannot last much longer. Computers have been shrinking from filling up a room to filling up your pocket, all while becoming way more powerful and cheaper. The technological advancements around the world is directly proportional to the growth of global automation, which is driven by the Internet of Things and cyber-physical systems. These systems will provide the foundation of our critical infrastructure, form the basis of emerging and future smart services, and improve the quality of our life in many areas. While Internet of Things takes care of the connections between objects and machines to the Internet, cyber-physical systems are machines in which a mechanism is controlled or monitored by computer-based algorithms. Other phrases that you might hear when discussing Internet of Things and cyber-physical systems are smart anything. Manufacturing, agriculture, cities, buildings, homes, pills, you name it. Connected machines will interact, visualize and make decisions autonomously. One of the data sources that feed the algorithms comes from the smart sensor systems in real applications. For example, in the healthcare sector, the data collected by smart sensors can help medical professionals understand critical situations faster and more accurately, and enable patients to be more informed about their conditions and improvements. The data, along with the devices themselves, are creating the Internet of Medical Things, a sophisticated health tech ecosystem that will pave the way for new technologies such as medical kiosks. When you think of medical devices, you often think of devices such as blood pressure monitors, glucose systems, or smartwatches. However, the US Food and Drug Administration have approved smart pills with an ingestion tracking system. The global smart pills technology market is expected to register a substantial growth in the future, owing to the increased prevalence of gastrointestinal disease, sedentary lifestyle, and high patient compliance on account of minimally invasive techniques. The medicine of the future is expected to be data-driven and, thus, highly personalized. The AI-based computerized diagnostics will basically change our comprehension of well-being. But that is not all. According to Kurzweil, we can scale the devices down to a few billionth of a meter. He predicts that by the end of the decade, we will have cell-sized nanobots in brains that connect us to the internet. There are already companies that are working on implant devices, which connect the computers directly into the brain. Neuralink, which is founded by Elon Musk, is developing implantable brain-machine interfaces. These brain-machine interfaces hold promise for the restoration of sensory and motor function and the treatment of neurological disorders. Researchers have demonstrated human neuroprosthetic control of computer cursors, robotic limbs, and speech synthesizers using no more than 256 electrodes. Musk thinks his direct brain-to-machine interface would help humans avoid becoming house cats to artificial intelligence. Humans, like computers, could be updated with additional intelligence in the future. This is not the only frontier that Elon is involved in. Besides Neuralink, Musk co-founded and leads Tesla, SpaceX, and The Boring Company. Tesla specializes in electric vehicle manufacturing, and they are already redefining the auto industry. In the next 10 years, the auto industry will undergo a profound transformation. The cars it builds, the companies that build them, and the consumers who buy them will look significantly different. Once found only in science fiction, fully autonomous cars are being tested on roads today, and the first commercially available autonomous cars could be on the road in the next 1 to 2 years. Connected cars, communicating with each other and with the larger world, will not only reduce accidents and ease traffic, they will have powerful effects beyond the auto industry. Insurers, for example, will have new ways to monitor driver behavior, reward good drivers, and distribute costs to the bad ones, and ride-sharing companies can better connect idle cars with the customers that need them. Another company that wants to revolutionize the autonomous driving is AutoX, a self-driving car tech startup backed by Alibaba. According to Zhao, CEO and founder of AutoX, the pandemic has made our society realize that we need self-driving cars for situations like this. Robo-taxi with its self-disinfecting capabilities and driverless logistics could save lots of lives. On other industry that will be most heavily affected by the rapid technology changes, such as Internet of Things and cyber-physical systems, is the manufacturing industry. Smart machines can work with humans for co-assembly tasks, but they can also operate autonomously and communicate directly with manufacturing systems. Leveraging the capabilities of the Internet of Things, these machines are able to access highly computing resources and carry on work beyond what they are initially programmed to do. By evaluating sensory input and distinguishing between different product configurations, these machines can solve problems and make decisions independently. This will have a strong impact on the factories of the future. For example, advanced manufacturing processes and rapid prototyping will make it possible for each customer to order one-of-a-kind product without significant cost increase. Collaborative virtual factory platforms will drastically reduce cost and time associated to new product design and engineering of the production process by exploiting complete simulation and virtual testing throughout the product lifecycle. Advanced human-machine interaction and augmented reality devices will help increasing safety in production plants and reducing physical demand to workers. Machine learning will be fundamental to optimize the production processes, both for reducing lead times and reducing the energy consumption. Cyber-physical systems and machine-to-machine communication will allow to gather and share real-time data from the shop floor in order to reduce idle times by conducting extremely effective predictive maintenance. Agriculture industry is also experiencing a fourth revolution triggered by the exponentially increasing use of information technology. This industry has seen many revolutions, whether the domestication of animals and plants a few thousand years ago, the systematic use of crop rotations and other improvements in farming practice a few hundred years ago, or the Green Revolution with systematic breeding and the widespread use of man-made fertilizers and pesticides a few decades ago. As the world's population booms towards 9 billion by 2050, the demand for agricultural products, food, fiber and fodder will rise dramatically. There are several smart solutions that can be implemented and scaled up in order to improve yields and meet growing food production demands. IoT sensors for light, humidity, temperature, soil moisture, crop health, etc. enable farmers to monitor the field conditions from anywhere. They can also utilize intelligent drones to track the routine activities of crop health and analyze vast amounts of data in seconds. With the ever-growing amount of data in every industry, the need to safeguard and manage the sensitive data has increased dramatically. Many countries are already implementing strict regulations, a trend that is likely to continue into the foreseeable future. Today, there are privacy concerns with respect to who receives the data and what is done with it. However, in the coming years, we could see an increase of decentralized technology adoption of protocols such as the IOTA Tangle protocol, which enhances data security, integrity, and
Thanks for watching. Do you like this video? Kindly like and share and subscribe for more.